Welcome to Lesson 5.6, Data Interpretation, Graphs and Tables. Understanding how to read charts, tables, and graphs is a crucial TEAS skill. In healthcare, you'll need to quickly interpret test results, patient charts, or lab data. The TEAS tests your ability to pull the right information from visual data formats and apply basic math or reasoning to answer questions correctly. Let's start with types of data visuals on the TEAS. On the test, you'll be asked to interpret different kinds of data visuals. Here are the main ones to know. Bar graphs are used to compare values across different groups. Line graphs show how something changes over time. Pie charts break down parts of a whole, showing percentages. Tables organize numbers or text into rows and columns for quick reference. And double bar or double line graphs help you compare two sets of data side by side. TEAS tip: before answering any question, take a moment to read the title, labels, units, and legends. They're the key to understanding the visual correctly. Let's go over how to understand the most common graph types on the TEAS. First, bar graphs. Focus on the height or length of each bar. That's what shows the quantity. Bars might be vertical or horizontal, but either way, pay attention to the units, which are usually on the y-axis, and the categories, which sit on the x-axis. For example, if the tallest bar is labeled Emergency Visits, July, and it reaches 300, that means there were 300 visits in July. Next up, line graphs. These use points connected by lines to show how values change over time. If the line goes up, that means the value increased. If it goes down, it decreased. But here's the trick. Always check that the time intervals are spaced evenly. Sometimes, graphs can be misleading if the time steps aren't consistent. Now, pie charts. Each slice represents a portion of the total, usually out of 100%. These are great for showing proportions at a glance. Let's say a pie chart shows that 25% of nurses work night shift. If there are 80 nurses total, just multiply. 0.25 times 80 equals 20 nurses. TEAS tip: no matter what type of graph you're looking at, always start by reading the labels, units, and legends before jumping to conclusions. Now, let's talk about tables. They may look simple, but they pack a lot of information into a small space. Tables are made up of rows and columns with labeled headers. Your job is to find the right intersection of row and column, understand what the values represent. Are you looking at patients, hours, percentages, or something else? Compare data across multiple entries. This helps with spotting trends or doing calculations like totals or averages. For example, here's a table showing the number of cases in different hospital departments by quarter. Now, here's a sample question. What was the total number of pediatric cases for the year? To solve, just add up the quarterly numbers for pediatrics. 120 plus 140 plus 135 plus 145 equals 540 cases. TEAS tip: be careful. Some questions ask for totals, some for averages, or even percent changes. Always double-check what the question is really asking. On the TEAS, reading the chart is just the beginning. You'll also be expected to apply simple math skills based on what you see. Here are 4 common tasks to prepare for. First, you may need to find totals. This means adding values from multiple bars, slices, or table rows. For example, if a bar graph shows medication errors as January 5 errors, February 3 errors, and March 7 errors, you simply add them up. 5 plus 3 plus 7 equals 15 total errors. Next, be ready to calculate differences. You might be asked how much something increased or decreased over time. For instance, if March had 10 discharges and April had 16, the difference is 16 minus 10 equals 6 more discharges. In some cases, the question won't give you exact numbers, so you'll need to estimate. Here, you rely on visual clues to make a reasonable guess. Example, if one slice of a pie chart takes up about 1/4 of the circle, you can estimate that slice as roughly 25%. Finally, You'll often need to find percents. This is especially common when comparing parts of a whole. For example, if 30 out of 120 patients are smokers, you divide 30 by 120. 30 divide 120 equals 0.25. Then multiply by 100 equals 25% of patients are smokers. TEAS tip: as you practice, get comfortable jumping between totals, differences, estimations, and percentages. These show up again and again, especially in chart-based questions. Now let's talk about a few common traps that can trip you up, especially when you're under time pressure. These visual questions aren't always about doing hard math. Sometimes they test how carefully you're reading the data. Here's how to stay sharp. First, double-check the units. Are the values shown in thousands, percentages, or actual counts? Mistaking one for the other can lead you to pick the wrong answer. Next, don't assume that a taller bar always means a higher number. Always read the y-axis. You may find that the bar just looks bigger because of how the chart is scaled. Also, be careful with misleading scales. Some graphs don't start at 0, which exaggerates small differences. This visual trick can make something seem more dramatic than it really is. Finally, always double-check that you're looking at the correct row or category. It's easy to scan the wrong line or column if you're rushing. Example trap. Let's say you're reading a bar graph and April has the tallest bar. It might look like a huge spike, but if the y-axis only ranges from 200 to 300, the actual difference may be very small. So visually it's dramatic, but numerically it's not. TEAS tip: slow down just enough to catch these little details. They're easy to miss, but just as easy to avoid if you stay alert. Let's wrap up this lesson with the key takeaways you'll need on test day. First, be comfortable reading and interpreting all types of visuals. That includes bar graphs, line graphs, pie charts, and data tables. Next, always start by checking the basics: titles, axis labels, units of measurement, and any legends. These guide your entire understanding of the data. You'll often need to calculate totals, find percent values, identify differences, or make visual estimates. So be ready for simple math mixed into the visuals. And don't forget, visual traps are real. Double-check the axes and the units. A long bar doesn't always mean a large value. Finally, stay organized. Use your scratch paper to jot down values, totals, or quick calculations. It'll help prevent simple mistakes and boost your confidence.